Okay, let's talk about dependent events. Dependent events occur, remember, when the outcome of one affects the probability of the next thing that happens. So here's an example. You select two cards from the standard shuffled deck of 52 cards. Both selected cards are diamond. And remember, as we saw in an earlier video, there are 13 cards of a suit in a 52 card deck. So what we're looking for is the probability of diamond. Well, let's do it the fun way. The probability of diamond, then diamond, which would be equivalent to the probability of diamond times the probability of diamond. Except, well, not except, we just have to pay close attention to these two probabilities not being equivalent. How do we do that? Well, before I select the first card, the probability of that card being a diamond is going to be our 13 over 52. 13 total diamond cards divided by 52 total cards in the deck. But now that I've already taken out a diamond, potentially, then I only have 12 diamonds left in the deck, and the deck only has 51 cards left in it. So there's a lot happening here. I think I'd want to, I don't like multiplying numbers this big, so let's see what we can do. Okay, I know that 13 and 52 are both divisible by 13. 13 times uh, 13 times 4 is 52, and 13 divided by 13 is 1. All right. I also know that 12 and 51 don't divide into each other at all. However, they both share a 3. So I can divide 3 out of both of those numbers, and 12 divided by 3 is 4, and 51 divided by 3 is 17. Now looking at the multiplication, I can multiply straight across, or I can recognize that 4 divided by 4 is 1, so I'll go ahead and cancel out those 4's, and I'll be left with 1 over 17. So the probability of drawing a diamond and then another diamond without replacing the card back into the deck is 1/17. Let's try another one. It says there are 10 shirts in your closet, 5 blue and 5 green. You randomly select one to wear Monday and then a different one on Thursday. What's the probability going to be that you wear blue shirts on both days? So I've got 5 blue shirts. See if I can do this pretty quickly. Got 5 of those, and I've got 5 red shirts. 5 red shirts. What's the probability of blue, then blue again? And again here, I right now have 10 total shirts in the closet, and 5 of them are blue, so 5 of 10. I'm going to multiply that with this goes down to 4 blue shirts in the closet. And now I still have the 5 red shirts, but that's now 9. So I'm going to multiply that by 4 over 9. And then I'll be able to simplify my fractions because it's easier that way. And I'll realize that I have 2 divides into 4 2 times. So the probability will be 2/9. So I have a 2/9 probability of choosing blue and then blue again on consecutive days. I want to take a look at one more just because I thought it was a really interesting question that I found on the Khan Academy. And there's lots of questions that are like this, but slightly different in the Khan Academy. They are all under the dependent events section in the practice, but you really have to read closely in order to understand what's being asked of you. So make sure you read and understand. Don't just try to answer the question by multiplying. Like, don't look at the number 2/5 and the number 3/8 and then multiply this. So let's read it together. It says, Captain Jessica has a ship, the HMS Crimson Lynx. The ship is 2 furlongs from the dread pirate Ishan and his merciless band of thieves. If her ship hasn't already been hit, Captain Jessica has a probability 2/5 of hitting the pirate ship. If her ship has been hit, Captain Jessica will always miss. If his ship hasn't already been hit, Dread Pirate Ishan has probability 3/8 of hitting the captain's ship. If his ship has been hit, Dread Pirate Ishan will always miss. So that's the information. Here's the question. If the captain and the pirate each shoot once, and the captain shoots first, so that's kind of important. Let's do the captain in blue, because it says that the captain shoots first. What's the probability that the captain misses? The captain misses, but the pirate ship hits. Now, the information that we were given wasn't the probability of the captain missing, it's the probability of the captain hitting. So we need to understand that the probability of a hit for the captain is 2/5, but that implies that the probability of a miss for the captain is 3/5, because you can either hit the pirate ship or not hit the pirate ship, and there's no in between. We are looking for the captain missing and the pirate. We want the pirate to hit, and the pirate we saw has a 3/8 chance of hitting. So for the pirate, the probability of a hit is going to be 3/8. All right, so let's take a look at what our probability is. Our probability is the probability that the captain misses whilst the pirate hits. The probability of a captain miss and a pirate hit, which would, of course, as we've done before, be equal to the probability of the captain missing times the probability of the pirate hitting. Now let's just replace. We saw that the captain missing is 3/5 probability, while the pirate hitting is 3/8 probability. And when I multiply those together, I get 9/40. So the probability of the captain missing and then the pirate hitting is 9 out of 40, 9/40. So that's going to be the probability of dependent events, where one event affects the probability of the next upcoming event.